Very good morning, my dear students. Welcome to the another session. Now we have almost finished the chapter called motion in a straight line, because there is a concept called motion under gravity. This is the chapter. A motion under gravity is already discussed by us in our basics. And let me mention here, already covered in our basic physics, right? Initially we have started with this, but still what we'll do is in detail analysis of motion under gravity we'll be doing in this session, right? It takes 2 or 3 sessions to understand different kind of numericals asked in competitive exams, right? Even of course in your PUC exam even. Now look at this carefully. Till the last class we have discussed motion in a straight line, whether the body is moving in this straight line or the body is moving in the straight line in this way. Now in motion under gravity we'll be discussing a body may be moving in this direction, or the body may be moving in upward direction or downward direction. Till the previous class we have discussed whether the body is moving in rightward direction or the leftward direction. Now upward and downward direction, straight line only. Some students may get a doubt that if a body is moving in this way, this is also a motion in a straight line. Understand, this is also a straight line. Whether we'll discuss this part in this chapter or in the next chapter. So this kind of question you may get it, right? Because the name of the chapter is motion in a straight line. And I have already told you motion in a straight line, the name of the chapter, and it is also called motion in one dimension. What is it called? Motion in one dimension, my dear students. A motion in one dimension. What exactly meant by the one dimension? Imagine if you consider a coordinate system. So this is the x-axis and this is the y-axis, right? This is plus y plus x minus x. This is the coordinate system, and you see this is the origin here. In this coordinate system, motion in one dimension means the body must move along x-axis or along y-axis. That's it. That may be positive or negative. Listen to me carefully. Motion in a straight line and motion in one dimension means the body either to move along x-axis or along y-axis. That's it. Here you see the body is moving along x-axis. The body is moving along x-axis. Here you see, in case of motion under gravity, the body is moving along y-axis and the body is moving along y-axis. That's it. Take this case. This is the case. Is this the case? The body is moving along x-axis or y-axis at least? No, right? So this is the body. We can say the motion of this body is motion in a plane. What is it called? Motion in a plane. What is meant by the motion in a plane we'll be discussing in the next class, right? So simply I'll tell you, look at here. This is the body is moving in a plane. You can draw a coordinate system for this. Imagine this is origin and see here. There is x-axis I have mentioned here and there is a y-axis also I have mentioned here. If you carefully observe at one point during its motion, right, you can see along x-axis, see, imagine x is in meters, y also in meters. What happens? At this particular instant, right, at this time, so the body is moving some x1 distance from here to here. At the same time, the body is moving at some y1 distance also. You can see here, this is y1 and this is x1. In this coordinate system, and this is the point, is x1 comma y1. You can see carefully here. So the body is not only moving along x-axis, it is also parallelly moving along, parallelly in the sense that it's also moving in the along y-axis also. Understand? So that's called motion in a plane. Alright. So in much more detailed way, we will be discussing this in the next chapter. Alright? Now, carefully, let's concentrate on motion under gravity. Body may be moving upwards or downwards to the ground from the ground, right? In motion under gravity, it is the best example for a uniform acceleration. What is that? Uniform acceleration. If a body is moving with uniform acceleration, it is 100% sure and clear that you can use equations of motion. Yes or no? Yes or no? You can use equations of motion. What are the equations of motion? Equations of motion we have is V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS, and so on. So those are the equations of motion you have. And you can also use them in motion under gravity. Let's discuss about this. And before moving to that, in this motion under gravity, imagine this is the ground. There are two cases. First case, the body is dropped or freely falling. What is it called? Freely falling. Freely falling body, initial velocity is 0. So the body is dropped and it is moving towards the ground. Carefully see. That's called freely falling body. So two cases are there in motion under gravity. Number one is a freely falling body, and you can also project a body from the ground. Project a body from the ground means there must be some initial velocity. With some initial velocity only you can throw the body upwards, right? So that's a U is not equal to 0 meters per second. That means there is some value. Maybe 1 meter per second, 0.5 meter per second, so maybe 2 meter per second, 20 meter per second, whatever it may be. Okay. So the body is thrown up to some heights. Alright? So to some height H. Here also, the body is dropped from some height H. In both the cases, uniform acceleration. See, let's see the second case. What is the second case here? Vertically thrown. What is the second case? Vertically thrown. Freely falling, vertically thrown. Two cases are there. In these two cases, the uniform acceleration, right? In these two cases, so the uniform acceleration is A. And this uniform acceleration in this case, due to what? Due to gravity only. When the body is moving up, the gravitational force will act downward. When the body is moving down, the gravitational force will act downward only. Understand? So this is the uniform acceleration, which is also called as acceleration due to gravity. What is that? Acceleration due to gravity. Listen, acceleration due to gravity. This concept also we discussed in the basic classes. And this acceleration due to gravity value is 9.8 meter per second square, my dear students. And this 9.8 meter per second square, sometimes we take it as 10 meter per second square. Depends on the question given. If they ask you to take 10, you take 10. If they ask you to take 9.8, take 9.8. Right? If they have not mentioned anything, take any value which is closer to your options. That's it. Okay. Now, this is acceleration due to gravity. Now, freely falling case and vertically thrown case, we are going to write the equations of motion. Right? Equations of motion in both the cases we will write. Before that, listen. When the body is freely falling, the acceleration is always towards the center of the earth. When a body is thrown up even, the acceleration is always towards the center of the earth. Acceleration due to gravity always will be towards the center, because acceleration direction and the force direction will be the same, right? Because F is equal to ma. So gravitational force direction is downwards and acceleration due to gravity also downwards, my dear students. Always acceleration due to gravity will never be zero. Always it will be there towards the ground, towards the center of the earth. Okay. Now, one more important point. When the body is freely falling, for example, its velocity will be increases, right? Because it is starting with 0 and it is increases and the velocity will reach the maximum value before striking the ground. As the velocity is increasing, we consider acceleration due to gravity value is positive. It's a sign convention, right? When the case of freely falling body, acceleration due to gravity we take positive. In case of vertically projected body, the acceleration due to gravity we consider negative because the speed is decreasing. Initially we are throwing the body with some speed, slowly the speed will reduces and finally at some point the final velocity of the body, for example, this is the point, imagine in vertically thrown case, at some point the final velocity of the body will become 0 meter per second. Because in vertically thrown case, what happened? Initially we are throwing with 10 meter per second. Slowly it reduces and finally becomes 0 meter per second. And starts coming back. Right? So this is called the maximum velocity. Right? So it's called the velocity at the highest point. Okay? Clear? Sorry, this is not the maximum velocity. Velocity of a body is at the maximum height. Okay? This is about the simple introduction of motion under gravity. Now we have equations of motion. V is equal to U plus AT. S is equal to UT plus half AT square. V square minus U square is equal to 2AS. Sn is equal to U plus A into N minus half. These are the equations of motion. Those are general equations of motion we have. Now, in case of freely falling body, and in case of vertically thrown body, vertically thrown object, how the equations of motion varies. Simple. V is equal to U plus GT because acceleration is replaced with the acceleration due to gravity in motion under gravity. Understand? So this acceleration is replaced with G, whereas we are discussing a freely falling body condition. In freely falling body condition, as the body will speed up, right? Initially starting with 0, it will increase its speed at G plus G. Understand? So this is plus G. And here S is equal to UT plus half AT square. This S is distance travel. Whereas in case of vertical thrown or freely falling, the body is covering some distance which is equal to height taken by the body. So that's what I wrote here, H. Right? So S will be replaced with H. H is equal to UT plus half GT square. Here also plus G only I have considered because I am talking about freely falling body, right? Let me write plus G. Vertically thrown, so minus G we consider. So now next one, V square minus U square is equal to 2G into H. Next one, Sn. So this I can write it as H suffix N, height covered by a body in a particular second. Understand? Distance traveled by a body in a particular second. Okay. So Hn is equal to U plus A into A is G here. So G into N minus half. As I am talking about freely falling body, initial velocity will be 0, my dear students. Initial velocity is what? 0. Okay. So everywhere you can substitute initial velocity 0. You get some other equations. Same, simple. It will be 0, it will be 0, it will be 0, it will be 0. That's it. These are the basic formulas, basic equations of motion when the body is falling freely. Alright? Now vertically thrown. So simple. G value will be negative. That's it. V is equal to U minus GT. See here plus G becomes minus. So H is equal to UT minus half GT square, and this is V square minus U square is equal to minus 2GH, because this G will be negative. Okay. So now Hn is equal to U plus G into N minus half. Is it correct? Is it correct? No, because this plus G is taken here. So it must be taken as minus G. That's it. Okay. Now, as it is vertically thrown, what is the final velocity of the body? Final velocity of the body after reaching the maximum height. Look at here. After reaching to the maximum height, the final velocity will be 0. Okay. Clear? So remember, in vertically thrown object, after reaching the maximum height, final velocity will be 0 meter per second. But acceleration due to gravity, but G will be downwards, right? G always downwards, even at maximum height also. G will not be 0, right? Acceleration due to gravity will never be 0 at maximum height. So body is thrown from here, so reaches to the maximum height. This is called H maximum. Final velocity will be 0. So then only the body will be coming back to the ground. But acceleration due to gravity will not be 0 here. So acceleration due to gravity will be acting always downwards towards the center, my dear students. Downwards towards the center. Alright. And one important thing I will tell you, this we had already discussed in case of gravitation. There is a possibility of acceleration due to gravity becomes 0. So see here, acceleration due to gravity is 0 meter per second square at the center of the earth. What is that? Where? At the center of the earth. But at maximum height, it will not be 0. Maximum height, only velocity is 0. Acceleration due to gravity will be there, right? So what is the value? The value is 9.8 meter per second square, and it is directed always towards the center of the earth, right? So let's concentrate now on freely falling body. Then we'll concentrate on vertically projected body, and the combination of both also will be discussed in the later classes, my dear children, right? So let's see the freely falling body conditions. Freely falling body. Right? Freely falling body, immediately you should remember initial velocity is 0 meters per second. Now, let's start. So, this is the ground. A body is freely falling from here. It will reach to a height h. That means from height h it is freely falling. The velocity before striking the ground is v, and the time taken to reach it is t, and it is freely falling under acceleration due to gravity g, right? In this case, let us apply first equation of motion. If you apply the first equation of motion, v is equal to u plus gt here, carefully see. V is equal to u plus gt here, what happens? Anyway, u is equal to 0. So then, final velocity before striking the ground, what is that? V is equal to gt. Okay, clear? So the final velocity before striking the ground, I'm writing here, final velocity before striking the ground. Keep it there. Let's use the second equation of motion. S is equal to ut plus half gt square. Here also, as it is freely falling, let us substitute u value as 0. So you get S is equal to half gt square. So this S I can write it or name it as h. H is equal to half gt square, right? So what is the height taken by the body, or what is the height covered by the body in a time t? Half gt square. Okay, so that you write here, height covered by the body. Height covered in a time t. Okay, and one more. From this only you get an equation. If you carefully see, it is t square is equal to 2h by g. From here t is equal to square root 2h by g. Carefully see, what is this equation? And this equation is time taken by a freely falling body to reach the ground, right? From some height, time taken by the freely falling body to reach the height. Now, and one more important thing, let's use v square minus u square is equal to 2gh formula. What is the equation you get? Let's find out. V square is equal to, anyway, u square is 0. V square is equal to 2gh. Right, from here what I can write, v is equal to root 2gh. Okay, so this is an equation is also giving you the final velocity of the body before striking the ground. Look at here, this is the equation also giving you the final velocity of the body before striking the ground. Understand? Clear? Alright, my dear children, is it simple? It is so simple. And why we have discussed all these things is, depends on the data given, you can get the answer. For example, they give g value as 10, t value as 10. Understand? So what is the final velocity before striking the ground? 10 into 10, it's 100 meters per second. Understand? So if they give g value as 10 meters per second square, t value is 2 seconds. What is the final velocity before striking the ground? It is gt, which is 20 meters per second. In this way you can solve the questions. But for example, they gave g value only. They have not given the time value. They gave g is 10 meters per second square. They give you your h value. This is the most important, you see here. H is 5 meter. So now they ask you to find the final velocity before striking the ground. It's simple. Final velocity before striking the ground. By using this equation, we have got an equation v is equal to square root 2gh. So let's apply root 2gh, which is square root 2 into g into h. Sorry, h is 5. H is 5. 5. So what is that? 5 into 2, 10, 10 into 10, 100, root 100, which is 10 meters per second. Alright? So in this way questions will be asked. Clear? So what is the time taken by the body to reach the ground? So this is also can be asked. Time taken by the body to reach the ground. Okay. So imagine here only, let me say, so given h is equal to your same 5 meter. Okay. So g is equal to 10 meter. So they ask you find the time taken by the body to reach the ground. So what is that? So 2 into h is 5 by 10. Okay, which is 1 second. Alright. Clear? So this is this question. Done. Height is given. G is given. So they ask you to find time. Time is equal to root 2 into height by g. You do it, you get 1 second. That's the time taken by the body to reach the ground. Okay, in this way questions will be asked. It's so simple, my dear children. So simple. Alright. Here itself, we will discuss about simple thing. Look at here. The concept is, these are the different cases or special cases you can consider. The concept is distance travelled by a body. Carefully see. By a body which is freely falling, we are discussing. Okay, distance travelled by a body in 1 second, comma, 2 seconds, comma, 3 seconds, so on. This is what we are going to find. We are not going to discuss distance travelled by a body in the first second, in the second second, in the third second. That's not the concept we are discussing. Distance travelled by a body in 1 second, in 2 seconds, in 3 seconds, in 4 seconds. It's not in a particular second. Now, look at this simple situation here. It's a ground. A body is freely falling, means its initial velocity is 0, right? Distance travelled by a body in 1 second. So that is S1 is equal to, anyway, U is 0, right? So half gt square. In 1 second, half into g into 1 square. It is g by 2. And before that, what is the distance travelled by the body in 0 seconds? It is 0, right? 0 meters. Now, distance travelled by the body in 2 seconds. In 1 second, the body may be travelled this distance, right? It is S1. In 2 seconds, the body may be covered this distance. It is S2. In 3 seconds, the body may be covered the distance. It is S3. So S2 is how much? Distance travelled by a body in 2 seconds. Half into g into 2 squares. So it is 4g by 2. What is the distance travelled by the body in 3 seconds? Half into g into 3 square. It's 9g by 2. What is the distance travelled by the body in 4 seconds? Half into g into 4 square. It's 16g by 2. Very important question for the NEET exam, my dear students. What is the ratio of distances travelled by the body in 1 second, 2 seconds, 3 seconds, so on? What is the ratio here? What is the ratio here? Is it simple? 1 is to 4 is to 9 is to 16, so on? This is the ratio of the distance travelled by the body in 1 second, 2 seconds, 3 seconds, 4 seconds, goes on. Not in a particular second. Remember this. This is one important thing I just wanted to write here. Now, very important thing. Distances travelled by the body, look at here. The distances travelled by the body in successive time intervals is distances travelled by a body in successive time intervals. That's the most important. Successive time intervals means what is the distance travelled by the body in 1 second? Okay, in first second. What is the distance travelled by the body in the second second? What is the distance travelled by the body in the third second? What is the distance travelled by the body in the fourth second? That's a concept. Distances travelled by the body in successive time intervals. It's so simple, my dear students. In first second, what is the distance travelled in first second? G by 2 minus 0. It's G by 2. Did you understand? None. And the distance travelled by the body in the second second. So it is minus this. 4G by 2 minus G by 2. It's a 3G by 2, my dear students. The distance travelled by the body in the third second. So this is the distance travelled by the body in the third second, which is a 5G by 2. And the distance travelled by the body in fourth second. So it is how much here? It is 16G by 2 minus 9G by 2. It's 7G by 2 here. Right? What is the ratio of this? what is the ratio of distances traveled by the body in successive time intervals? What is the ratio of distances traveled by the body in successive intervals? That's the most important. What is that? You can see g by 2, 3g by 2. So I am writing g by 2 is 2, 3g by 2 is 2, and 5g by 2 is 2, 7g by 2 is 2. G by 2 if you take common, right? What is the ratio you get? 1 is to 3 is to 5 is to 7 is to. It goes on like that, and this is the ratio, and these are the numbers. There is a name for these numbers, right? So this is the Galileo law of odd numbers. What is that? Galileo law of odd numbers, you can see. Which numbers and which ratios we call the Galileo's laws of odd numbers? So that is the distance traveled by the body in successive time intervals. In this time interval, next time interval, next time interval, next time interval. So that also indicates, and that's also named as distances, the ratio of distances traveled by the body in first second, in second second, in third second, in fourth second. It goes like that. Alright. Let's see the second case. This is the ground. From here, there is an object is freely falling here. The time taken by this body is t1. 1 meter is the distance traveled. Time taken by the body is t2 when the distance traveled is 2 meter. Time taken by the body is t3 when the distance traveled is 3 meter. Okay. Now the concept here is, we have the formula time taken by the body to cover some particular distance. T is equal to square root 2h by g. Right? So here what we are going to do is, carefully see, time taken by a body in covering 1 meter, 2 meter, 3 meter, so on. Alright? Now, T1. What is T1? Square root 2h by g. Alright? Which is square root 2 into 1 by g. So, this is root 2 by g. That's T1. And time taken by the body in covering second 2 meters. Okay, time taken by the body in covering 1 meter is T1. That we got. Time taken by the body in covering 2 meters from here to here, right? Which is T2 is square root 2 into h is 2. So, which is root 4 by g. Time taken by the body in covering 3 meters, which is 2 into 3, which is 6 by g. Okay, and one more, time taken by the body in covering 4 meters, it is 2 into 4, it's 8 by g, root 8 by g, it goes like that. Direct formula only we have used here, nothing else. Now, the question is, see, and before that, there is a T0 also you get it, right, from here. So, from here, T0 also you get it, time taken by the body in covering 0 meters, so which is root 2 into 0 by g. Okay, root 2 into 0 by g. Okay, so that will be 0 by g. So it's 0. Okay. Now, the ratio let us find out. So what is the find out here? What we are going to find here is the ratio. This is finished. Ratio. Galileo of odd numbers is done, and this is also done. Okay. Now, the ratio of time intervals of a body in covering successive distances. Carefully see, successive distances. The same way, successive time intervals, how we have done? Same way it is successive distances. Now, ratio of time intervals in covering successive distances. First thing, t1 minus 0, right? So that is t1 minus 0 is to t2 minus t1. So this interval, this is what the successive distances covered. So here t1 minus 0 and it is t2 minus t1 and it is t3 minus t2, it is t4 minus t3, right? Everywhere root 1 by g is common. You can see root 1 by g, root 1 by g, root 1 by g, root 1 by g, root 1 by g is common, right? So what is remained? Let me write t1 minus 0, root 2 minus 0. See here, root 2 minus 0. Already root 1 by g is taken out. So root 2 minus 0. t2 minus t1. It's root 4 minus root 2 is to t3 minus t2. Root 6 minus root 4, which is to, and here root 8 minus root 6. Root 8 minus root 6. Here also, everywhere you take root 2 common, right? So this is 1. Here from root 4, root 2 if you take common, root 2 will be left. Minus, already root 2 we have taken common. 1 is to, root 2 minus 1 is to here. From root 6, you can take root 2 common. It is remaining root 3. From root 4, if you take root 2 common, it is root 2 is left. Right? Is to goes like that. So remember, this is the ratio is also very important. The ratio of time intervals of a body in covering successive distances. The ratio of distances travelled by the body in covering successive time intervals. This is called Galileo's laws of odd number, and this is just a ratio. Remember, these two are very important, my dear children. Clear? Just practice some time and let's discuss vertically projected body. The basics of vertically projected body we'll discuss. In the next classes onwards, we'll be merging vertically projection and the freely falling body both, and we'll discuss a lot of cases. Let us discuss about vertically thrown body. Vertically thrown object from the ground. I had clearly mentioned to you, if this is the ground, we are throwing a body vertically upwards, means there must be some initial velocity. It's not zero now. But as this initial velocity is decreasing, at some particular point its velocity becomes zero, and this is the height at which the velocity is becoming zero, and that is called the maximum height. Okay, what is this height called? Maximum height travelled by the body from the ground, which is at which point the velocity is becoming zero. So that is the maximum height travelled. There is a time taken to reach the maximum height, right? So that is t. And here also acceleration due to gravity is g, small g only, right? Now, let us take the equations of motion here also. We have equations of motion. V is equal to u minus gt, because plus g in case of freely falling, it's minus g in case of vertically thrown. So here S is equal to, S in the sense it is H. H is equal to ut minus half gt square, and v square minus u square is equal to minus 2gh. In all these cases, if you consider the maximum height, h is equal to maximum height, then final velocity will be 0 meter per second, remember. Okay. Let's consider h is h maximum only, right? So what is my consideration here? So h is equal to h maximum only. That means final velocity I can substitute as 0. Okay. So let's take the first equation. First equation, v is equal to u minus gt. So v is 0, which is equal to u minus g into t. From here what I can write? So u is equal to gt, and from here t is equal to u by g, my dear students, right? So what is this t? Time taken by the body to reach the maximum height. All right. What is this t? Time taken by the body to reach the maximum height. So this is also called as time of ascent. What is that? Time of ascent. Ascent means moving up. So the time of ascent from here to here, it's called u by g. After reaching to the maximum height, what happens? After reaching to the maximum height, definitely the body will move back to the ground, right? This is the most important thing. The body will start moving towards maximum height, and after reaching to the maximum height, it will start moving towards the ground. Okay, so how much time it took to reach the maximum height, the same amount of time it will take to come to the ground. The most important thing. Okay, for example, imagine the body is taken some 10 seconds to reach the maximum height. The same 10 seconds the body will take to reach the ground. So time of ascent is always equal to time of descent. So time of descent equation will be equal to, so what is that? So time of descent is also equal to u by g, I can write, my dear students, because both are same. Time of ascent and time of descent. Most important thing here. With what velocity you have thrown the body, with the same velocity it will reach back to the ground. Imagine we are throwing the body with 10 meters per second. With the same 10 meters per second, the body will reach back to the ground. Right? So what is the change in velocity in this case? Here most of the students get confused. So change in velocity is how much? Total change in velocity I am talking about in its total journey. Starting from ground to reaching maximum height, from maximum height to reaching ground. What is the total change in velocity? Final velocity minus initial velocity. Yes or no? Final velocity minus initial velocity. What is the final velocity, my dear students, here? So the final velocity is 10 meters per second, for example, 10 meters per second minus initial velocity is how much? 10 meters per second. Most of the students will write it as 0, but it is a wrong answer. Okay, what we have discussed, change in velocity, change in speed may be 0. So change in speed is 0. Because there is no direction is involved. Change in velocity, there is a direction is involved, my dear students, right? As there is a direction is involved, change in velocity is not 0. So 10 meters per second minus of minus, because final velocity 10 meters per second, the body will move in this direction. Initial velocity, the body is moving in this direction. Both are opposite, right? One direction if you consider positive, the another one must be negative. So 10 minus of minus 10, it is 10 plus 10. So the change in velocity will be 20 meters per second, which is equal to 2 times the initial velocity. Okay, clear? Now, let's use this equation, right? So what is that? V square minus u square is equal to 2gh. V square at maximum height only we are talking about, and v is equal to 0 meter per second. 0 square minus u square is equal to minus 2 into g into h maximum. So this minus u square is equal to minus 2g into h maximum. Minus minus cancel. This is the most important point. H is equal to, that is h maximum is equal to u square by 2g. Remember this. What is that? Maximum height taken by the body, right? U square by 2g, right? So questions can be asked here. For example, initial velocity of the body is given as 10 meters per second. So they gave you, take g value is also 10 meters per second. Find the maximum height taken by the body. It's so simple. u square by 2g you apply. The maximum height taken by the body u square, it's 10 into 10 by 2 into 10. 10 cancel to 5. So it is 5 meter. What's the maximum height taken by the body in this case? 5 meters. Okay. Clear? In this case only, can you find the time of ascent? Time of ascent can you find? T suffix a, which is equal to u by g. Already I told you. What is the time of ascent formula? U by g. What is u by g here? U is 10, g is 10. 10 by 10, it's 1 second. Time of ascent is 1 second, and obviously time of descent will also be 1 second, and time of flight. Time of flight is time of ascent plus time of descent. 1 second plus 1 second is 2 seconds. Time of flight means the total time taken by the body in air. So that means total journey. So this is time of ascent and this is time of descent. Total time taken by the body to reach the ground from the ground. It's 2 seconds. Right? Time of flight. Time of ascent plus time of descent. Okay? Clear? Now, change in velocity also. Let us find. So change in speed is 0 meters per second, whereas change in velocity is equal to, so it is 10 meters per second, right? So going with 10 meters per second, coming back with 10 meters per second. Change in velocity means direction you need to consider, and this is 10 plus 10, it is 20 meters per second. Okay? Clear? Now, velocity at maximum height we discussed. Sometimes the question will be asked, what is the velocity at half of the maximum height? Did you understand? Right? Look at this. This is the ground. Body is moving like this and finally reach to the maximum height. At half of the maximum height, look at here. At half of the maximum height, you know, the velocity of the body is u by root 2, remember. At half of the maximum height, the velocity of the body is u by root 2. See, this is the point. Velocity is decreasing, keep on decreasing. At some point, half of the maximum height, the velocity is u by root 2. Remember this. You can also derive it, but it's not required. And you can derive it if you want by using equations of motion here. Now, for example, at this height will be at 3 by 4 of maximum height. What is that? 3 by 4 of maximum height, the velocity will be u by 2. Remember those two values, my dear students, and they're very important for the competitive purpose. Alright? At half of the maximum height, at maximum height velocity is 0. At half of the maximum height velocity is u by root 2. So if u is 10, your answer is 10 by root 2. At 3 by 4 of maximum height, the velocity will be u by 2. U by 2, for example, if u is 10, 10 by 2 is 5 meter. It goes like that. Decreases. Okay? Clear? So let us give me the assignment. Let me give the assignment. So be ready for the assignment by revising today's session and the previous basic session. Right? I hope you have got the previous basic sessions link, so which you have already practiced yesterday or day before yesterday. Okay? So all the very best.